Hello dear students. In this video, we will see how to delete a node from a circular linked list. It will be almost same as that of linear queue, except for one if statement that we will have to add. Just check that I have drawn a circular queue containing 10, 20, 30, and 30 is next, as you all see, is pointing back to 10, the front node. So how do you delete a node from a circular list? Of course, we will pass address of the queue as usual to this delete function. So the pointer p will point at q. Now run this code where there are two temporary variables, x which is integer and temp which is a node pointer. So there is a temporary pointer which can point to a node. This is temp pointer, and check this next line I am underlining. Temp should point wherever front points. And as you all know, p arrow front is pointing at 10. So temp will also point at 10. This is a temporary pointer we have kept here so that it will be very easy to free the memory and return it back to operating system. Now, next line is X should become front's data, whatever is stored at front data, because we want to return this data because this is the data, frontmost data that will be deleted, and P arrow front arrow data is 10. So X is 10 and finally we will return this back to main. Now comes the big point. There is a if statement here which asks, is P arrow front equal to P arrow rear? Now this is a very simple question we are asking. We are asking, is it that front and rear both are pointing to the same node? No, not at all. At this instance, front is pointing to the node which stores 10. So front has some different address, and rear is pointing to a node which stores 30. So rear has different address. So the addresses stored by front and rear are not same. That means they are not pointing to the same node, isn't it? So we are going to land in else, and in the else we have written P arrow front equal to P arrow front arrow next. Now this is obvious. Everybody knows this. Come on, you tell me, if we are going to delete 10, if we are going to delete this value 10, then 20 should become front. That means whatever is the front's next right now, this next should be where the front points. So I am updating this front pointer, and this front pointer no more points to 10 but points to 20. Great. But then there is one more line, you watch. One more line over here. This is so important. Now, tell me, 10 has got deleted, isn't it? 10 has got deleted. Is there any other adjustment that you have to do? Yes, of course. If 10 has got deleted, how come 30's next will still point there? Now, 30's next should point to 20 because 20 is the frontmost. Only then we can have circular queue. So this adjustment has to be done. That has been done in the second statement of the else. The second statement of the else says rear arrow next. That means last node's next should point wherever front is pointing. Note that front is pointing at 20. So rear arrow next will now point at 20. Great, isn't it? And then what's remaining? Free temp. You know, temp points at 10. So we are freeing this. Freeing this means we are returning this memory back to operating system. Isn't it so? So this is the fresh queue that we are having with front pointing at 20, rear pointing at 30, and 30 is next pointing back to 20. Now, I would like to now talk about that if in particular. If P arrow rear equal to P arrow front, why is that condition written? Just check. I'm talking about the condition which was not written in the linear queue. Let me take you to the page of linear queue. Watch, this is the delete function. This is the delete function of the linear queue. Now you still have a statement in this, P arrow front equal to P arrow front arrow next, which you have over here also, P arrow front equal to P arrow front arrow next. You have that statement, but it has been written in if else. Why really? Let's talk about this. So to understand why that condition is needed, let us assume that we have called delete with queues front pointing to 10. This is the first node, so frontmost node, and rear also pointing to 10. That can very well happen if this is the only node remaining. There is only one node in the queue. In that case, next of this 10, please try to understand this. Next of this 10 will point back wherever front is pointing. What if there was 10 and there was 20? Then 20 is next will point to 10 because 10 is the frontmost. But now we have only one node. So the next of this 10 will point back to itself. This is the circular queue. To handle this situation, we need that if to handle this. Suppose we call delete with address of queue stored in P. Now if you run this, there is a temp pointer and you know that this temp pointer has been made equal to P arrow front. That means temp pointer will point to the frontmost node. And then X is made equal to front's data. So X is made 10. We are going to finally return this value. We ask, is front equal to rear? Is front and rear pointing to the same node? Yes, of course. That means we are deleting such a node which is the only one node remaining in the queue. Then we will instantly make front and rear both. Oh, I'm so sorry for typing mistake here. Front and rear both will be made null. Come on, you tell me this is the only node and we are deleting this. Then where does the question come in saying front, you better point to the next node? There is no next node in the queue. So if we are deleting this only node, then we will instantly make both front and rear pointers as null because the queue is becoming empty. There is nothing in the queue now. But what's the way to know that there is nothing in the queue? To know that there will be nothing in the queue, you will have to ask, is front equal to rear? Is this the only node pending in the queue? If this is the only node, make both pointers null. Otherwise, advance front to the next node. Because if we are deleting 10 and there are a lot of nodes and front was pointing to 10, if we are deleting front and rear is of course at 30, if we are deleting 10, then front should advance to 20, isn't it? And then rear arrow next, this statement I am talking about, should point to the new front. So these two lines in the else will run only when there are more than one node, isn't it so? And of course, after that free temp, after the if is needed so that we will release the space occupied by this only node that was occupying the space in the memory is also released. And finally, we return X. So that's how the delete function is written for circular queue. I have also written one more function called display. The display function over here is same as that of linear queue, except that there are there is a printf inside while loop and there is printf outside while loop. This extra printf has been written. It will be a good challenge for the readers or the listeners or the students to know how this functions by taking a simple example 10, 20, 30 you can take on paper where next points to 20, next points to 30 and next of 30 points back to 10 with front pointing at 10 and rear pointing at 30. You can execute this code and understand. Just check that this while loop which has been written is exactly same as that of the linear queue, except in linear queue, we have written while numeric not equal to null in the display function. We had written this condition, but here we have written numeric not equal to p arrow rear. Come on, I cannot compare anything with null. There is no null pointer in circular queue. Absolutely, you will find nothing to be null. Search null if you can. How there can be null? In linear queue, we had 10s next, 20, 20s next, 30, 30s next null. So we can search for this null in linear queue, but there is nothing called null. So what we will have to do is we will have to check whether numeric reaches the last node, that is p arrow here. So have a look at this and just try to understand this. And then I have written destroy. Of course, I have written destroy in all the codes, but I say that it's not so important. You can check it on your own. Finally, I have written the menu driven program in which, as usual, I have asked the choices to the user and I have declared all these functions. The program starts from here, declaring the node, Then queue data structure, which contains front and rear. These are declarations of all the functions. Then main is menu driven, as you can see, correct? And then the case one is for insert, case two for delete. Of course, before calling delete, we will check whether the queue is empty or not. If it is empty, we will print underflow. If it is not empty, only then we will call delete. And then case three is display, case four is destroy, and case five is exit. And that's the end of main. So this is how circular queue is maintained and implemented in C language. Thank you very much.